Currently, cell phones are not capable of communicating with other planets in our solar system. The distance between Earth and other planets in our solar system is so vast that it requires specialized communication technology to transmit signals over such long distances. The most common method of communicating with spacecraft in our solar system is through radio waves. NASA's Deep Space Network is a system of antennas and communication facilities that allows scientists to communicate with spacecraft in deep space. These signals are sent at very high frequencies and require large antennas and high-power transmitters to be detected by spacecraft that are millions of miles away. Cell phones, on the other hand, operate on much lower frequencies and have much less power. In addition, they are designed to communicate with cell towers on Earth, not with spacecraft in deep space. In summary, while it is technically possible to develop communication technology that would allow cell phones to communicate with other planets in our solar system, current cell phone technology is not capable of this feat. To expand on the topic, there are a number of factors that make communicating with other planets in our solar system a challenging task. The distance between Earth and other planets varies depending on their position in their respective orbits. At its closest approach, Mars is about 34 million miles away from Earth, while at its furthest, it can be over 250 million miles away. This distance means that radio signals take anywhere from 4 to 24 minutes to travel one way between Earth and Mars, depending on their respective positions in their orbits. Furthermore, the signal strength weakens as it travels further from the source, which means that the signal received by a spacecraft at another planet will be much weaker than the signal that was transmitted from Earth. This requires that the signals be amplified and processed in order to be detected and decoded by the spacecraft. In addition to the distance and signal strength challenges, there are also issues related to interference from other sources of radio waves, as well as the effects of the space environment on the communication equipment. For example, solar flares and other space weather events can cause disruptions in communication, and the extreme temperatures and radiation in space can also affect the performance of communication equipment. Despite these challenges, scientists and engineers have developed sophisticated communication technology that allows us to communicate with spacecraft in deep space. This technology includes large antennas, high-power transmitters, and specialized signal processing techniques that enable us to transmit and receive signals over vast distances. Let's just talk about the planet Mars. On an ideal day, it takes a strong radio signal about 3.09 minutes to travel from Earth to Mars. So you would reply, "Hey Charlie, how's it going?" As a communication cannot travel faster than the speed of light, the reply would arrive more than 6 minutes later. On a terrible day, the distance between the two planets can be covered by light and radio in more than 22.5 light minutes, 45 minutes for the answer. Mars is 12.72 light minutes away on average, but the animation below shows how that distance varies during the day. Some days, Mars, Earth is behind the Sun and there is no signal at all. Mars orbits the Sun more slowly than Earth does, which is why it is sometimes on the same side of the Sun as Earth and other times it is completely on the opposite side. What all this means is that talking to someone on the phone here on Earth will not be like talking to someone on Mars. Voice and video messages will be packaged and sent as packets. The signal can then be unzipped and seen or heard once it arrives at the target planet. A reply can then be sent.